Okay, we're on. Question 5 was a nice Summer Series one. It seems quite reasonable here. Notice that they always say this, fully factorised form. So we need to be aware that at the end of this, whatever we do, if we're going to expand anything, we need to put it all back together. But let's see what happens. So we've got the sum, it's r equals 1 to n, so they're not playing any tricks on us with that. That's always a good thing to check, isn't it? That we're starting at 1 and we're going to a single n value. But that's exactly what we want, so we're really happy with that. We remember that to do this, we need to split this up. This is 4 times sigma r cubed minus 3 times sigma r squared plus sigma r. So let's pull all of that together. R cubed, now which one is in, that's in the formula booklet, isn't it? I can't remember which one is and which one isn't. R cubed is, and that would be 4 times, and that's a quarter n squared n plus 1 squared. Have you remembered that right? And then we're taking away 3r squared, and r squared is in the formula booklet as well. So we're taking away 3 times 1/6 n plus 1 to n plus 1. And then we're adding sigma r, and that's not in the formula booklet, but it is the square root of that one. So we can kind of remember it's a half n plus 1. Right. So we're going to have to factorise this. That's it done. That is the series expansion of that. You know, we found it. But it's not in fully factorised form by any stretch of the imagination. What have we got here then? For some reason I'm writing it out again. Right, it looks like we've got some good common factors going on. It looks like we've got a half would make a sensible common factor. It looks like n appears in each term, and it looks like n plus 1 appears in each term. So that seems like a good thing to pull out. Let's pull out a half n plus 1. Which gives us, well, if that is a 1 times at the front, this must be 2n plus 1. Because that would give us 1 n squared n plus 1 squared. Here we've got the half and the n and the n plus 1, so there's a minus 2n plus 1. And here we've got the half, we've got the n, we've got the n plus 1, so it's a plus 1 at the end of that. Don't fall into the trap of just thinking, oh, that's all there, and not writing anything. It's 1 times that we're taking out. So, half n plus 1 inside the big square bracket. There is, well, there is 2n squareds from that bit. There is plus 2n minus 2n from that bit, so there's no n's at all. There is minus 1 plus 1. So there's no numbers. Is that right? So we're left with just 2n squared. So as we pull all of that together, we've got a half times 2, which is 1, and we've got n squared times n, so n cubed, n plus 1. And I think that was the answer that we were looking for. Yes, it was. There we go. And it must be in fully factorised form. So slightly strangely, out of the 6 marks, the last 2 were for this answer, and if you ended up with n to the 4 plus n cubed, that got you one of them, and if it was factorised, that got you the second one. I'm not sure that it would be particularly a sensible way of working to end up with n cubed plus n to the 4, but anyway. So anyway. And notice it's much better, isn't it, to try and factorise as much as possible as you go along. Although, of course, multiplying everything out does allow you to get to the answer. Did anybody multiply everything out? Did you get to that answer? Feels like a long way around, doesn't it?
Because you easily forget stuff like the button. That's sort of the only thing.
The danger is that if it's more complicated than that, then the thing that you're multiplying out to factorise it is quite hard work. There we go. That's all. That's math.